Hi, everyone. Hope you enjoyed the first day of the main event. I definitely did. Thank you for staying for the second part of the day. For me, this is my fourth ETHDenver, and I always come back with great joy. Today, I want to talk about how to build a practical framework and basically walk you through the different choices you should take when assessing an Oracle solution. So let's get started. But before that, we are here at ETHDenver, an event for builders. So I would like to challenge you with a little question. So I would like to know, what do you consider when you build a DApp? What sort of choices do you have on your mind? Can we hear some options from the audience? Anyone? OK. Well, I wrote some down. The first thing that I put over here is chain. One of the first considerations when building an Oracle, when building a DApp, you want to know, OK, on which chain am I going to build? Another important consideration you might have are gas fees. And actually, gas fees are tightly the consideration of gas fees is probably very connected to choosing the chain. So are incentives. You might look, OK, what incentives do I have for building in this ecosystem versus another one? Similarly, you might look into the liquidity in that ecosystem. Or if we're talking about a novel ecosystem, the potential of that ecosystem to attract liquidity. You might also consider the user experience in that ecosystem, and so on. There are like very many choices that builders have to take when building a DApp. But unfortunately, I think there is one overlooked choice, and those are oracles. Unfortunately, discussions about oracles are quite rare. And there is this misconception that all oracles are the same. I think mainly this comes from the fact that the name itself can be a bit misleading. You can see on the right side the definition from Merriam-Webster. And it basically implies that it's an unquestionable source of truth. In reality, not all oracles are equal nor infallible. And here is what happens when there are different Oracle failures. The top two Oracle failures are flash loan attacks and market manipulation. And you can see on the right side some of the most famous, if you want, cases in the ecosystem of Oracle failures. Now, the good sign is that the good news, I know this might sound frightening, especially since oracles are a key piece of infrastructure, and you're going to need them for building your DApp. But the good news is that these oracle failures can be avoided. And in fact, you can have truly decentralized, verifiable, and robust oracles for your application. Now, before I move forward and walk you through the framework of assessing the right Oracle solution, a few words about myself. My name is Bianca Buzea. I'm lead DevRel at Chronicle. Chronicle is the team behind the first Oracle on Ethereum. In 2023, it spun out of MakerDAO, and now we offer the same oracles for the ecosystem. In terms of Oracle flavors, I want to walk you through three types of oracles: push oracles, pull oracles, and optimistic oracles. Let's start with the first one. This is also my favorite one because push oracles are proactive. They proactively provide data to smart contracts. So you might think, for example, when there is a certain trigger, for example, a condition, you might have like the new value different by a certain delta from the previous value, then you might want to update the oracle gets updated. Or similarly, you might have a condition based on time. Every X number of minutes, let's say every 10 minutes, you want the oracle to update. Now, pull oracles, on the other side, they're a bit lazy. They require the smart contract itself to request the data explicitly. So in the case of pull oracles, the smart contract sends a query to the oracle, retrieving and relaying the requested information to the contracts. Now, the last oracle type I want to talk a bit about are optimistic oracles. Similar to optimistic L2s, those take some time to have data finalized. So basically, optimistic oracles, they assume that data submitted, it's accurate unless actively disputed. And they have a challenge time. You can see here in the picture, at time t, you have the value, then you have a certain number of minutes for the challenge, and then the price is considered finalized. Now, before going into the framework itself, I also want to talk a bit about the different types of data that Oracle can deliver. It's true that technically an Oracle can deliver any sort of data, but the most widespread, if you want, use cases are crypto price data, non-crypto price data, and attestable data. So let's take them one by one. When we're talking about crypto price data, I'm referring here to real-time pricing for different cryptocurrencies. Then when it comes to non-crypto price data, here you might have stuff like prices for fiat currencies, stocks, commodities, etc. And last but not least, and probably the one with the most potential nowadays, given the growth of real-world assets, it's attestable data. So here we're talking about any sort of verifiable piece of information. And here are some widespread examples, if you want. Again, when we're talking about real-world assets, are proof of funds and proof of ownership. Now, finally, as I promised you at the beginning, I want to walk you through a 6-dimensional framework for choosing an oracle. So which choices you should make when you're picking an oracle. I want to mention from the beginning that the order itself, it's not that important. What is really important is to go through all these steps. The first one I put here is operational history. So when it comes to Oracle, you will want to look into how this Oracle has been operating over the time. Has it consistently secure funds over time? Did it have like any hiccups? And here, of course, operational history, and the longer the Oracle has been around, the more reliable it is. Longevity signals reliability. Another important consideration here is total value secured, or TVS. This is also considered the golden standard, if you want, when it comes to oracles. So here, basically, we're asking ourselves, OK, how much value does this oracle secure? You can see on the right side, top 10 oracles by TVS from DeFi Llama. And here, of course, TVS means battle-tested. Kind of signals you additional confidence in the Oracle solution. Next, you want to think about decentralization. And I would like you to think about 3 factors here. The first is having multiple nodes, then having independent validators, and having diverse data sources. And I want to take them one by one. The more nodes an Oracle solution has, the more robust it is. But now there is a caveat here. It's not enough that all the nodes are run by the same entity or a majority of the entities. You want here independent validators. Even when the intentions are sound, if you have most of the nodes run by the team, for example, those can be prone to different errors, or they can be susceptible to attacks. Similarly, here, you want to look into having diverse data sources. Ideally, you want a combination of on-chain data sources, such as DEXs, and off-chain data sources, such as centralized exchanges, with very good liquidity, with an emphasis here on the importance of liquidity. Next, I want to talk a bit about validators and node operators. Validators are also called node operators, depending on the Oracle ecosystem you're looking at. So when it comes to validators, you want to look at who is running the network for the Oracle. Ideally, you want trusted independent validators that bring higher levels of data integrity and network security. Also here, it's very important the reputation of those validators. The higher the reputation the validators have, the more incentives they have to maintain that reputation and to make sure that the data that they sign is correct. Number 5, I put here data sources. So you might want to look into what data sources does the Oracle rely on. Again, here you want tier 1 reputable data sources with established credibility, high liquidity, and a proven track record. If you're using on-chain data sources, such as DEXs, you want to make sure that at least 2 data sources are on the chain or are on the same chain in order to enable MEV bots. And finally, when it comes to data sources, you want to have traceability and transparency across data sources. And what I mean by that, you want to have mechanisms in order to check what are the data sources used by the Oracle and to be able to verify those data sources. Finally, I put here operating costs. Oracles are gas expensive, especially when it comes to periods of network congestions when the gas prices are high, then it can be very difficult to cover the gas costs if you don't have the right Oracle solution. You might think, okay, one way to address this issue is to just lower the update frequency. But the problem with that is that you're going to end up with stale data. What you want to have instead is to have mechanisms that reduce the gas costs that associated with the Oracle without compromising the data freshness. For example, in the case of Chronicle, we're using Schnorr signatures to put together multiple signatures into a super signature. And this allows us to reduce gas costs up to 68%. Finally, I want to leave you with some final thoughts. Please remember, not all oracles are equal. They can literally break your protocol. Please keep in mind the different choices you need to make in order to assess the right Oracle solution for your protocol. And finally, I want to leave you with this acronym, NODDOT, which stands for Node Operators, Operational History, Decentralization, Data Sources, Operational Costs, and TVS. Thank you.